That was gold.
So it'll lose any of that content.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 290. We'll be talking about iPhone's electric glue, Winamp's source code, and Sonya's beautiful instructions. First of all, amazing news. Hackaday turned 20 years old a few weeks ago, and we didn't even notice.
Too busy covering the hacks. We didn't get a chance to look at the calendar.
Well, I'm not even 100% sure we know exactly when the first post on Hackaday came out. It was originally run as an experimental sub-blog over at Engadget. Phil Terone started that up, and I don't know. The first post we have is from early September 2004.
Yeah, the timeline's a little hazy.
So September 2024 minus September 2004 is exactly 20 years. Congratulations, Hackaday.
Yay.
Reader Undersampled wrote in to let us know that we had turned 20, and I'm like, oh my God, we are. So we are in panic mode, thinking of what kind of celebration we're going to do. If you have any great ideas, head on over to the links here and help us out. What are we going to do? A giant retrospective? I mean, we kind of did that at 15. A giant birthday cake?
We'll have to send the slices all over the world.
Every reader gets a slice of Hackaday birthday cake.
But we did do a retrospective for 15, and I guess that's why it seems so weird that we're at 20, because it feels like the 15-year posts just went out. But there was COVID in between there, and things got kind of weird with the timeline. But Mike, did the 15-year anniversary post and kind of gave some interesting stats, and I enjoyed that he went back to black and white pictures with the tape holding them onto the page. I always liked that look, so he worked that back into the 15-year post. And then one of the things I kind of thought was interesting, we were talking about it earlier, is that he says, it's been 15 years to the day. So I guess Mike knows when the first post is.
Mike's on time, yo.
Yeah, call him up and ask when the first one is. But he says, it's been 15 years to the day, and we've published 34,000 and change articles. And I was thinking, that's weird, because now we're at 20 and have 53,000. But then, we kind of were thinking about it, and somewhere along the line, we really kicked into gear with running a lot more stories per day, which I don't know. There's a reason it's called Hack a Day, right? If you go back far enough, there was actually one post a day.
A hack a day.
And it turns out that's not sustainable for a website. Just if anybody out there is thinking about doing something similar, it's not going to work.
We'll have to go back and look, actually, whether it was 5 years or 8 years. I know the kind of big inflection point was when we got picked up by Supply Frame, and that was kind of year 12, I think. So it doesn't surprise me that there's this 35,000 by 15 and 50,000 by 20. The last 5 years have been kind of Hackaday's best 5 years in a way. We picked up a whole bunch of new writers. Frankly, we got an infusion of extra money through Supply Frame handling our advertisements better than they were doing previously. Picked up new writers, started writing original content articles. Yeah, there's a lot more going on now than there ever was before. So yeah, go last 5 years of Hackaday.
Yeah, that'd be an interesting thing to look at. When did for those who might not realize, we run 2 original pieces every day, but it wasn't always the case. But then we kind of always have had stuff from the writers that at least that they were working on. That goes back to the beginnings, but it wasn't as structured.
Yeah, I don't know how much we want to get into deep Hackaday history, but it was actually just after the time that Supply Frame bought Hackaday that Mike decided to see if he could step up the original content pieces. And actually, that's when I came on, just exactly at that time, and started writing a lot of long form stuff. So it was good timing for me. It was good fun.
See, this is the stuff that could go in the 20-year post.
Oh, we're writing the 20-year post right now.
I think so, yeah. I think this is happening.
Okay, well, somebody take notes here. Another crazy thing that happened in the intervening years, I guess, is SuperCon started up. And we're looking at SuperCon number 8, which is our 10th SuperCon. We took 2 years off
Very
for COVID. Remoticon and Remoticon 1, but SuperCon 8 is our 10th SuperCon coming up November 1st through 3rd in Pasadena, California. We just announced the second batch of speakers. We got one more speaker announced coming up, and then the keynote speaker, and then the badge. Ay, we've got a lot of SuperCon news. So if you haven't gotten your tickets, all of this insane hype is going to push a lot of people over the edge. So get your tickets now before they do. Speaking of speakers, a bunch of people have signed up for lightning talks, but we still have space. So if you want to give a 7-minute talk, it doesn't have to be hyper formal, but it just has to be 7 minutes of something hacky to say to the Hackaday audience, then by all means submit your lightning talk proposition. Yeah, lightning talks are kind of loose and ad hoc and fun, so we're going to be accepting submissions until the very end, but if we run out of space, we run out of space, and we might have to select the talks in chronological order. So if you're thinking of giving a lightning talk, don't wait on it.
Take some of the pressure off, right? Because it is kind of a big ask to do a full presentation, but you might have something that you're willing to talk a few minutes about, and you don't necessarily have to have visual aids or anything. So I think it's a really cool on ramp for giving a talk to a very engaged audience that will be happy to hear you.
Like 7 minutes is one hack. Everybody out there has one hack that they'd like to tell people about.
Yeah, there's something they can talk about for 7 minutes for sure.
Yeah, it's just really fun. It's a great way to get your ideas out there without having to invest the time in putting together a whole 40-minute slide deck.
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to What's That Sound? This is a game where we play a crazy sound, you guess what it is, and one randomly selected correct answer gets a Hackaday podcast t-shirt. But until we reveal what that is and who that is, Tom's going to have to guess.
Yeah.
Yoo-hoo!
Come on. Okay, here we go. Listen in now. Oh, wow.
Mm-hmm. Mm-hmm.
It's not a bunch of people shearing sheep, is it?
It is not.
It sounds spinny.
Yeah?
Um,
Do you want me to give you the same hint I gave Christina and our listeners? That is that I was at a vintage computer festival a couple weeks ago, and I recorded the sound there live.
So maybe like a disk drive or something?
Not a bad guess.
It doesn't sound as noisy as like a printer would be.
More vintage than that, even.
More vintage than a disk drive. Oh boy.
I think so.
I mean, I don't know. The only thing I can think of before that would be like one of those old school like regulator AC to DC things that spun.
Right.
But that's too old. That's too far. That's like
That's too old. That's too old.
that's prior. Yeah. I give up. What is it?
I won't lie to you. I couldn't believe this thing when I saw it / heard it. I expected it to make a totally different noise. It is a paper tape punch machine. So it's printing out in principle code onto one of those long, paper ticker tape things where it just punches it.
Wow, really?
That thing was going fast.
It's interesting. I don't hear any kind of what I would think of as like a punching noise. It just
Exactly.
It
was just grrrrat. And that's because it's punching so damn fast that you can't even hear it. It's crazy. And it was actually printing out Hello Hackaday from VCFE with a little heart. You could the oil on this machine and the heat that it produced was very aromatic. It's definitely it smelled like typewriter oil or like sewing machine oil.
You see, that's something I don't know that we've ever, a virtue we've ever extolled about the vintage computer festivals. You get the smells.
Oh, you do?
If you haven't been there and know what those old computers smell like, that's worth going to a VCF event, on its own.
I was in the back corner of this one. This year's theme was actually 8080 based computers, and someone brought their entire collection of educational kit computers. And it was really interesting. There were a bunch of them were from universities around here in Germany and stuff. And one of them, I was joking with the guy. I'm like, it's amazing that these things still work, because he was just keying them up and flipping the switches and hit store and flip the switches and hit store and then the thing runs, right? And I'm like, wow, that's pretty cool. It's an amazing longevity. And he's like, you have no idea how much work I have to put into this thing to keep it running. And he's like, in fact, we can't even really run it for more than like 15 minutes before it starts to overheat and smoke starts coming out of it. And so we're joking around and he's showing me the op codes and I'll be damned if I can't smell it.
Oh, that old circuit board smell, that really,
Yeah.
something about it. It's probably terrible for us, whatever we're smelling, but
we
like formaldehyde or something.
We had to shut it down for a little bit and let it have a rest. 50-year-old computer, it needs a rest every once in a while.
I like you inadvertently belittling this guy's work. Like, oh, it must be so easy to keep these things running. All you have to do is take them out of the box and plug them in. And he's shaking with rage.
Well, especially given he had a collection of like 18 of these things in all various, and they were all running, right? And he must have gotten them all running to bring to the show because that was the theme. And so, yeah, good job, Elliot. Good job. Anyway, we got about 7 answers that are close enough to correct that I'm going to take them. A lot of them were like punched paper tape reader. And this was actually punching it, not reading it, but I think I'm going to give it to you. I draw the line at dot matrix printer, which this wasn't. Teletype, for instance, also not. Davip mentioned the Usagi Electrics one, and I think we actually featured that probably the week before on Haggaday. He was working on building a kind of period correct tape reader. Again, it's a reader, not a writer, but same basic idea.
Readers. And I mean, now we mention it, when I was at VCF East, somebody had a homebrew reader, and they're just like an optical kind of thing.
Exactly. And the reason I'm accepting both is that almost all of the readers had writers built in. So actually, it's not super separate. But this machine was a dedicated writer, and it was fast. Enough talk about tape machines.
We're really in the weeds now.
We are deep in the weeds. I got to roll some dice. Here we go. I got 7 answers. I got an 8-sided die. And the answer is 2. Oh, congratulations to Davip. Paper tape reader, maybe even Usagi Electric's own. No, it's not. But good enough. I'll take it. Congratulations to Davip. I'll send you an email, get your shirt size, and get you a Haggaday podcast t-shirt. Everybody else out there, keep on listening. Everybody else out there, keep listening next week for your chance to win. And actually, I know a few of you have t-shirts that are still pending. We had a change of office managers at the Supply Frame office, and some of the t-shirts got delayed. So if you have a t-shirt that's still missing, I'll get in touch with you and you can let me know, and we'll get you another one ASAP. Well, off to hacks. I'd like to start off with Find My Power Tool Battery is a sweet little hack by Beamster. These days, battery power packs for power tools come with Apple compatible Find My tags. So in case, you're at the job site and somebody steals your power tool, you can find it later on. In a less sinister use case, you leave your power tool off at the work site or your mother-in-law's, which is where I leave my tools occasionally. Then you can figure it out without even having to call your mother-in-law. In this case, it's a Tuya BT17L Bluetooth module. But what's really cool here is that Beamster's been working on other chips and integrating them into the kind of open source Find My tags ecosystem. And so actually doing the hack on this battery, he's like, I'm going to start this and it should be easy. And he's like, and those are famous last words. This little project will never end. 2 days later, there's a post on his Haggaday.io project that's like, oh, well, that was easy. Project's done. So, it was a weekend project that actually was a weekend project because he'd done previous work on other microcontrollers with the software. And so this all is courtesy of the Open Haystack library, which is an open source version of the Apple Find My tags put out by the CMU lab, which is a computer security lab at TU Darmstadt here in Germany. There's some really cool people there doing really cool security work and making it all open source. So I'll throw the links to Open Haystack in the show notes. What was great about Open Haystack is that it was developed really quickly after the Find My tags came out, but it required you still to have an Apple computer to run Apple's software on to find out where your tag is. And since then, people have worked on that. And I think the most promising project now is probably PyPush, which I'll also put links for, because implementing the tag part is super easy, and there's example code out there for doing it on every microcontroller you can think of that has BLE, from like the ESP32 to the NRF51 series, to the weirdo microcontrollers you've never even heard of that are in the $1 AliExpress tags. So totally useful for the transmitting side. But then when you want to collect the data and find out where the heck your tag is, you have to either have an Apple Macintosh or use some of this more new software like PyPush, which just requires you to have an Apple ID, which one you can get for free, and set it up with SMS two-factor authentication. And then you can find out where your own tags are, and you can make your own tags out of anything that supports BLE. So it's a party.
I think that's kind of an interesting segue to my takeaway from this, is that, the battery already has, a BLE capable microcontroller in there, and it kind of speaks to how far these batteries have come. I mean, they're not really batteries. I guess, there are literally batteries in it, but they're not just batteries. I mean, they have a lot of smarts built into them.
I don't know. This is something like, it's so easy to get a Bluetooth enabled microcontroller these days, and the code's all out there. And with people working on the receive side, on the Apple's API side of things, it's getting easier to do it all over the place. And yeah, I want to see more Apple AirTag hacks.
Well, speaking of my general distrust of anything implemented by Apple, the first one I wanted to talk about this week is a hands-on with the iPhone's new electrically released adhesive. Now, I got to tell you, the release of a new iPhone is possibly one of the things I care about least in the world. Every time they put one of these things out, all the articles on all the, let's call them the mainstream tech sites, they're all a Twitter about whatever the new thing is, and I just kind of tune it out. But in this case, whether we like it or not, I believe this is going to be a technology we're going to increasingly run into. And the whole thing here is that from a repairability standpoint, the modern smartphone is pretty bad. If you've tried to take apart one in the last few years, you'll probably know that they're all glued together and you got to heat them up. And, getting them open is one thing, but doing it without breaking something worse, and then getting them closed again and retaining its waterproof capabilities and all that is really tough. It's the kind of thing that, it can be done, but man, you really would rather do anything else. And I mean, I speak from experience, not with an iPhone, but I have a phone where the power button broke on the side, and I know it's just like a little micro switch and I can change it, but like just taking the screen off and scraping the glue, and it's just like, nah, forget it. I'll just buy another phone. And I feel bad about it. Apple's solution, as it were, is a electrically operated adhesive, I guess you could say, and it is still a glue of some type. But instead of using heat, you actually apply a low voltage to it. It says 9 up to 30 volts, apparently. Some people have theorized that it heats it up, which would be kind of similar to like a regular adhesive, but it actually is, the way it's explained is that it just chemically debonds because of the voltage applied to it. So you're not left with the sticky residue and all that from a more traditional adhesive. You just put in this example, a 9-volt battery on it, wait a little bit, and it just releases. That's pretty cool. But the even cooler thing is that if you flip the polarity, it will reattach. So I don't know how many times you can do that or anything like that, but at least for the purposes of opening it up and changing a battery, you can reattach it the opposite of how you took it off. And, I will go out on a limb and say probably everyone listening to this would rather they just use screws, right? We have a way to open and close devices that doesn't involve, voltage being applied to a hidden pair of terminals. But acknowledging that that's out the window, right? I think, modern super thin devices, they need something more high tech than the traditional screw. And if the choice is between this and some nasty glue pad that you have to heat up or, scrape off, I gotta say this seems like the lesser of the evils. And, history kind of tells us where Apple goes, a lot of the industry follows. So I think we're going to start seeing more of this, and at the very least, other phones. But, beyond that, I'm kind of curious, is there a DIY application for this? I don't know how many home gamers would necessarily want to use this, but it's another tool in the toolbox. So I'm kind of interested to see when we might see, a non-Apple kind of generic version of this that we could use for our own creations if we are tired of the classic screwdriver.
Yeah, I don't understand. I mean, I do understand your negativity, but I don't understand your negativity at all here. I think this is awesome. I think electrical tape, tape that undoes itself electrically is pretty rad. And actually, I'll throw a link in the show notes to the first time we ever heard about this. It was before the Apple phone came out, even. They were talking about it in June this year. Maya wrote up a piece on the particular tape that they're using, and I think it's awesome. I went following the links here. It's made by the European tape-making giant, Tesa, and they make a lot of industrial tapes. So I went clicking through some links there, and it looks like it's only for industrial clients so far. They're like, if you have a problem that needs this solution, get in contact with us and we'll make a special run tape for you.
Bring a check with you.
Which is secret code for if you have to ask, you can't afford it. But still, I think that's really awesome. And it can't be very long before that becomes like that, that rubbery, whatever that elastic tape is that when you stretch it, it comes undone. That's like called contact strips and stuff and other things. That was an industrial adhesive first, and then they found a bunch of cool consumer uses for it. I'm sure that they will find some like stick a picture to your wall household use for this stuff, and and then it'll get mass produced, and then it'll be cheap, and then we will all be playing with it.
Yeah, I could even like imagine the infomercial. There's like some little handheld gadget that you stick on there and it charges it to make it stick, and
they sell you the 12-volt battery. In a fancy plastic widget that undoes
it'd be like a little handheld thing.
It's like the UV things that they sell you to go with the UV epoxy.
Exactly.
Right?
Exactly. Oh, yeah, you'll see I got to put a picture up here and put this little thing up there, wait until it beeps, and then the little adhesive puck is stuck to the wall. Oh, yeah. I can already... Hold on, I got to go...
This is good.
I got to go make an investor's pitch real quick.
Excuse me, I got to go make $1 million. I'll be back.
No, yeah, absolutely. And I should say, like, I'm not against it. Like I said, this is better than the alternative, which is things you can't open. It's right. Just I would rather we didn't have to go down these exotic roads in the first place. But I recognize that the construction of the modern smartphone is a lot different than stuff we're used to taking apart. So I guess it was only a matter of time before we had to put our trusty screwdrivers down.
All right. Well, from me, most powerful laser diodes now even more powerful. This is another video by Les Wright, who has been doing the coolest things with lasers lately. You should really check out his channel if you like lasers. This time he's taking those become affordable high-end blue laser diodes, the ones from Nichia, in particular the 6-watt ones, which are the super high power ones. And 6 watts of laser is, is pretty all right. And what Les wants to do with it is like pump dye lasers, which is where you hit a fluorescent dye with something that can make it fluoresce so much that it actually turns into a laser in like a little cuvette. And those are cool because you can pick different chemicals and get super fun different colors out of them and stuff like that. Anyway, that's his end application, I'm guessing. He didn't say as much, except he did point to an academic paper where they did that. 6 watts isn't quite enough to do a dye laser. He needs more power. And the question is, how are you going to get that out of a 6-watt diode? And some people have played around with overdriving them and using extreme feats of cooling, getting them up to like 8 watts. Les's trick here is super short pulses, and he's able to drive the thing up to 30 watts, I think. But the trick is, of course, the really short pulses, so it doesn't burn itself out. And that's what this video is mostly about, actually, is him making a 7 nanosecond pulse driver circuit. And he made a bunch of them, and they're really beautiful looking. They're all based on the super old AppNote 47. It's an avalanche pulse generator. This is a beautiful circuit made by the prolific Jim Williams. And what it does is you take a transistor, in this case just a cheap BJT, like a 3904, and you put the voltage across it backwards, and you increase the voltage the wrong way across it. When it fails by some electrons tunneling, which then cause an electron cascade. And it's this avalanche that makes a very fast rising edge. And then you just build the circuit so that it quenches itself once a little current goes through, and it repeats. And that's how it goes. AppNote 47 is like amazing because it gets like picosecond pulses out of parts you can buy for like $5, and you probably have sitting around right now if you're me. Or Jenny, who wrote this up in 2016 and built herself an AppNote 47 pulse generator. I'll throw the links in the show notes. A quickly hacked together avalanche pulse generator. She actually does it on scrap PCB and like scrapes the solder resist off to like solder to it. It's the most horrible hacked project you've ever seen. Anyway, this is the circuit that Les uses to drive these lasers and make a bunch of quick pulses. So it's doing short pulses, but repeated a few thousand times a second. So it looks continuous to your naked eye, but it's not.
I guess if you're familiar with high-powered lasers used in, whatever, fusion and stuff, this is kind of how the trick, it always works, right? Like they'll do a ridiculous megawatt laser blast, but for 1/1000th of a second or something. So this like pulse super high power thing is extremely common in like the scientific field, but is absolute voodoo for like DIYers, and especially so simple, really. I mean, it is like you said, a very straightforward little parts bin circuit. That this isn't some crazy rack of electronics that's producing this like tiny little pulse of up to 80 amps, which is kind of, I mean, it's mind-boggling to think, pushing 80 amps through this little like laser pointer diode,
right?
Yeah, not for long, just long enough to get something to happen, but not long enough for it to turn into a puff of smoke. And in the comments, people are saying, "Oh, it's going to destroy the diode." Like, probably, but what are they? $10 for these like diodes? I mean, they're so cheap anymore, leading to the explosion of these like cheap diode laser cutters and stuff. Now, I mean, these things are nothing. If that's the sacrifice you have to make to burn out a couple of these diodes to do something cool, I don't think anybody's gonna bat an eye.
He cites an academic paper in there where they have one of these things running for like 10 hours or something, and the color doesn't shift at all, suggesting that you could do this forever.
And 10 hours is probably millions of pulses, right?
The average power coming out of this thing, these are nanosecond pulses 1,000 times a second. So, what is that? It's divide by 1,000. The average power is probably milliwatts coming out of this thing.
Yeah,
right? So if you average it out, the average power is nothing. So the thing's going to stay cool. It's just the peak power is honking.
I'm kind of surprised, almost. It's one of those things where, like, when you see how easy, well, I shouldn't say easy, but, how you can implement this in the home lab. I am kind of surprised we haven't seen more of this, like, pulsed laser stuff. But it could just be, like, there's not a whole lot of obvious applications for it for experimentation. Like you're saying, it probably is going to be doing some kind of, dye excitation, which I think Styropyro did years. I don't know if we wrote it up or I just watched it, but he was trying to make like the most powerful flashlight, and his approach was to excite some fluorescent fluid with a bunch of blue lasers, and that would that would produce a blinding light. But I think he ran into some problem where like the fluid was boiling.
Yeah, right.
Like there was so much laser energy being pumped into it. So like outside of that, I don't know what exactly you doing a home fusion thing. I mean, if you are, please let us know. But
I guess it's good for short pulses are good for ablating stuff. So if you wanna the ones,
you could do that maybe.
The like CO2 lasers that they use to eat copper, to ablate copper off of circuit boards are like zap zap zap. Like they're lots and lots of little, very big pulses.
Like the tattoo removal lasers are similar.
Yeah, totally. Totally.
So yeah, that could be. I guess that's the possible end game: home tattoo removal lasers. I mean, send it in if you do it, but I won't be the first in line to try it out. Well, this one I think will be an interesting story for those of a certain age. If you were online in the 1990s and were there for the boom of MP3s and Napster and all that kind of stuff, you almost certainly will remember Winamp, even if you haven't thought about it since then. It was kind of the de facto MP3 player for a while there and spawned all kinds of clones. And what most people probably don't know is that they are still out there. Winamp is still kicking. I think they went through different acquisitions, and although the world may have moved on to streaming services and stuff, they're out there still trying to push the product. And they have recently released the source code for Winamp. And you might say, well, this is great. This is going to help aforementioned clones and other stuff like that. We're going to get the secret sauce for Winamp, and we're going to be able to bring it to new platforms, and we're going to have Winamp on our phones and on our microcontrollers and all kinds of stuff. A little bit of a gotcha here, because the source is available, but it is not what would officially be called open source by the definition. And that's because there is a clause in the license that effectively says, while you can look at the source code, you are not allowed to basically do anything with it other than you could fix it for them. Like if you see a bug, you could fix it and send it in, and they will accept that. But you can't make any kind of forks. You can't spin it off into something else. You can't really use the code in your own project for the same reason. And you might want to call this like the Highlander clause, like there can be only one. Like they don't want there to be other Winamp spinoffs. Like they want Winamp to be Winamp, but at the same time they want to take all the benefits of having the community look at the code. And from their standpoint, I think we could all get it, right? I mean, it makes sense. Why not? If you have people out there who are willing to look through your code and fix it and will abide by these rules, sure. To the point of they have, they call it the Winamp Collaborative License, which I think kind of says it right in the name, right? They want you to collaborate with them, but just don't collaborate with other people. This is just a secret between you and Winamp. But it's a bummer for us, for the community, because there's, I guess there's certain value in seeing the code, maybe even like from a historical kind of standpoint. But, if you can't spin it off into something else, if you can't fork it, you can't port it, there's not much we can do with it. And this is not by any means the first time this has happened. I mean, there's a whole category of licenses that are kind of referred to as source available, where you can look at the source, but you can't really do anything with it. Microsoft was very famously released some of their early stuff under the Microsoft Shared Source Initiative, which again was like, okay, hey, you can look at the source, but you can't do nothing with it other than tell us why it's amazing and why we're so great. And it was kind of a knee-jerk reaction to like the growth of open source. Even Microsoft was like, okay, we gotta do something. We gotta get involved here. But they weren't ready to fully commit. And I guess that's kind of like, that's the headline, right? This is like dipping the toe into open source when you're not really to actually commit to it and free up the community. You wanna say in the press release that, oh, we've opened our source and we're doing this and we're reaching out and we're gonna work collaboratively, But you don't actually want to like take the leash off your IP. And it's kind of like an electrically activated glue on your phone. Is it better than not having access to the source code? I suppose.
Yeah.
But it's still not the ideal.
Look, if I take the most charitable view I can to this, and like I wanted a feature on Winamp, I could now implement it and push it back to them and say, hey, I did this. What do you think? And then I would at least get that feature, right? And like maybe other people would too through Winamp if they decided to, take my pull request or whatever. But it's not open source. It's not like, everybody has their own ideas and the cool ideas win. It's still Winamp controls it, but it's open.
And I have no doubt that people will. Like you said, they'll fix a bug. And I think as long as there's credits list somewhere where you can get like some kind of little bit of clout or whatever, I think people would do it. Just say, hey, I fixed that bug in Winamp, like that'll be something they put on their resume. they're not worried about whether they can maintain their own fork. I mean, they don't want to do that. I mean, who really does, want to maintain a whole fork of Winamp just to fix one bug or push some feature in there? But even if it's just, on an about page hidden somewhere that says Elliott Williams added this feature, I think that'll be more than enough for plenty of people to do free labor.
You know what is free? Ideas are free. And here's a great idea. 3D printing on top of laser cut acrylic is an exploration of the mashup of two different easy fabrication techniques. That is laser cutting acrylic and 3D printing. Julius Kurt says, ¿Por qué no los dos? And 3D prints directly on acrylic. This is an exploration of 4 techniques that he's developed. And it starts off with the really simplest one. He glues the sheet of acrylic to his printer bed and then he prints directly on it. And he uses this for like illuminated front panels, for doing the marking on illuminated front panels. I think it's in an escape room he made, but he says they've held up for a long time and it actually looks pretty good. The PLA sticks very nicely to acrylic. And I think what's cooler for me was the rest of the video where he starts looking at some of the qualities that acrylic has. Like it's brittle, which is crappy, but it's super transparent, and good luck getting a 3D printer filament to look that transparent. And it's pretty strong, and it's very flat, and it's heat formable and bendable. And so those are kind of acrylic superpowers. And then 3D printing, you can make it into arbitrary shapes, and it's just so much more flexible, but it's not transparent. And so the question is, how can you make these two things work together? And one of the cool things he does is he builds like a puzzle box for his daughter, prints it out, and then he stops the print. He puts the acrylic in there, and then he kind of puts a gasket around it and glues the acrylic face to the front of this puzzle. So it's got like little beads, and you have to run them through a maze on the inside of it. But to me, that looks like, oh, this is a great way of making faceplates for 3D printed projects. This idea of, pausing it and then kind of working a piece of acrylic into it. But he does some others where he test prints a handle onto a piece of acrylic and tries to rip it off to see if you could imagine you have a box that's made out of acrylic, a display box or something, and it needs feet so that it can stand up on your desk. Doing the feet also in acrylic and gluing them on there, it's going to look janky. Doing nice feet in PLA is easy. Probably just about as strong a bond if you print them directly onto the acrylic itself. And I think that's pretty cool. Where I think there's even more room to grow is he hasn't pushed the laser cutting of the acrylic side very far. And I think what's neat about this is that you have a design file that you can send off both to your laser cutter to cut kind of arbitrarily interesting shapes into the acrylic, and you've got the design file that you're doing the 3D printed parts with. And I think there's going to be some sort of really interesting overlap there when somebody figures out the application that needs this kind of incredible blend of the two different kinds of materials, and then also the arbitrary resolution and precision that these kind of digital manufacturing methods have.
Well, I'm glad you kind of touched on that at the end, the laser cut part, because I got to say, I think we may have done this project a slight disservice with the title of the post, because there's really nothing to do with laser cut acrylic. It says 3D printing on top of laser cut acrylic, and I think that maybe would give you the impression that, I don't know, you have to do something with the laser to make the print stick to it. But it's really nothing to do with laser cutting it so much as that would be a potential expansion where you could then cut the acrylic to, a very specific shape. But like, to be clear, nothing stops you from just throwing a piece of acrylic on your bed right now and printing on top of it. And that's really what this is about. It's about the fusion of the extruded filament to the acrylic panel, which turns out to be exceptionally strong. I hope people didn't get the idea they have to it had to be a laser involved, because there's obviously a lot of stuff you can do here just with like a hand cut piece of acrylic. I mean, if you're just trying to do like a square, you don't need a laser cutter to do that. A sharp blade and a straight edge is enough to give you a nice little rectangle, and then you chuck that up into the printer. And we didn't get too deep into the method here. But to make this possible, what Julius does is in his CAD software, he essentially just has the printer do like a little fence around the acrylic to get it up to the top level, because you figure the acrylic's whatever, 1.5 millimeters, 2 millimeters, depending on what it is, and you got to get the nozzle up that high before it can print on the top surface. But that's actually not necessary. He has to do that because he has a Prusa that uses a magnetic sensor to see where the height is, and obviously the acrylic will not affect that, so the nozzle will just smash into it. But if you have a printer that uses like a mechanical switch for bed leveling, or if you don't have an automatic bed level at all and you can dial in your Z height, you actually don't need to do that part at all. You could just factor in the height of the acrylic as 0. So you could print directly on it without having to essentially waste time and material doing this, brim around it. So if you were really into this technique, you could have like an alternate Z height set up in your slicer that like, this is the acrylic height that we use when we're printing on front panels. So I think there's a lot of possibilities here, especially with refining the technique a little bit and seeing what works and what doesn't work. And again, it's one of those things where it's like yeah, duh, like this, why did we not see this before? It makes perfect sense to print on, acrylic is such a, so it's cheap, it's easy to work with. We see it all the time in projects, and everybody pretty much has a desktop 3D printer, and it is a little surprising that it's taken this long. Not to say no one's ever tried it, but to take it this serious and say, what can we really do with these two common tools? And I think a lot potentially.
Makes me think of those other kinds of multi-material prints, like where you print over fabric. So you print like into tulle or something, and it makes a support for that. That's awesome because it gives your 3D print an easy, fabric-y, flexible quality that otherwise would have been hard to design in. Here, I think printing on top of a piece of acrylic gives you a nice, flat, transparent surface for free that you otherwise would be hard-pressed to get. And so, instead of having to glue a window onto the front of your project box, why not just print the project box around the front window and, do it the other way, and it's all in one piece. I think there's a bunch of neat examples here, and we're just seeing the beginning of it.
I mean, I have a personal example that is actually exactly that. I wanted to make storage boxes for my back catalog of 2600 issues, because 2600 comes in this weird format that nobody seems to make a box for. It's like a digest size, but not really, or something. Anyway, ultimately, I had to make my own boxes, and I had got the acrylic cut to size, and I glued them together, but the end caps are 3D printed, and I left like a void in the middle, and I cut a piece of acrylic and glued it into that opening. But I definitely could do exactly what we're talking about here. You could print it, pause it, put the acrylic in there, and then like kind of seal it in. So assuming 2600 keeps publishing and I have to make more boxes, the new boxes will probably use that technique.
I actually secretly am going to refer back to this later, so I'm not going to spoil it.
Oh,
I'm holding something up my sleeve here.
Intrigue.
I tell you what.
It's almost like, let's print on everything. Like
yeah,
seeing this,
right?
And like you were saying, like you print on the fabric and acrylic. Okay, that's 2. Like let's print on all the things. Like what else can we print on? And can we, abuse this capability? Like, there's got to be more combinations. I guess that's really what this got me thinking of. What other things? Can you print? Can you print on paper? Would the plastic stick to paper? What would that be? What would you do with that? I don't know. A lot of interesting possibilities there. Well, this last one I wanted to talk about. This is Stratosaur Glider Flies Itself from High Altitude, and this is just a really cool project from Charlie Nicholson. And it is an attempt to build a low-cost, open-source, highly accessible, all the good stuff, platform for a glider launched from here, a high-altitude balloon, but I guess it could be really anything. It's starting from a high height and coming back down to Earth. Charlie, he says in the documentation that he wants to kind of like open this up to more hobbyists, experimenters. There's all kinds of potential applications for this, from, point-to-point deliveries to just doing high-altitude research and environmental stuff. I mean, it's one of those things where you don't know all the applications until you get the technology in your hands, right? Well, when we say low cost and accessible, I mean, this is about This is about as accessible as it gets. Charlie experimented with like building a custom airframe and like 3D printing wings and all that stuff, and then in the end found that a foam glider from the toy store pretty much worked better than whatever you could make, and is super cheap and is available. So why reinvent the wheel? You take this foam glider, you hollow out some areas for your servos. You got to actuate control surfaces on the back, and you hollow out the nose so you can put the electronics in there, and off you go. It really simplifies things. So this project, at least in its current stage, it is just the electronics part of it. It doesn't get lost in trying to design a hyper efficient glider. Not to say that might not be some further evolution of it, because this toy store glider is not exactly designed for stratospheric scientific missions, but it's good enough for now. It's good enough for developing the electronics. So, like I said, the project really takes the form of an open source electronics package on a custom PCB that has your microcontroller, the inertial measurement unit. It's got plugins for the GPS and sensors and all kinds of modules, and obviously the electronics necessary to drive the servos. And it's all powered from a tiny little 60 one of those tiny little toy drone batteries, and it can run forever on there. Basically, it's again, it's a glider, so there's no motor here. It's just moving the rudder a little bit here and there, and obviously the software is a big part of this. And again, that is open source, and it has a lot of for a hobby project, for lack of a better word. It does have a lot of features where you can either glide directly to a target, say like you want to go to this field or whatever, or it can follow a series of waypoints if you have a more complicated route you want it to go. And you can imagine if you were doing something like taking photos or something, you'd want it to fly along a certain route instead of just taking whatever the most expedient route is. And then once it gets there, there's some options where it could either enter like a spiral kind of thing where it just spirals down to the ground, or depending on the altitude, it could try to do just a more traditional landing, or it could even pop a chute and just drop straight down, which may be the easiest thing if you just want the thing back on the ground quickly. You don't worry about what it looks like. Just pop the chute and drop straight down. So a lot of really cool stuff in here. This is very much an ongoing project. This is the Mark II of Stratosaur, and it has flown, and there's video of that. There are still bugs to be worked out, and Charlie is currently working on the third version, which has not flown. So it's really interesting to see this develop. And I think offhand of a whole lot of applications for this. I have to say no, to be perfectly honest, but I am always excited to see new capabilities put in the hands of us, whether you want to call that, hobbyists and scientists, whatever it is. Really cool stuff, and looking forward to seeing the continuing test flights. And Charlie, I got in contact with him, and he said he would be keeping us updated on where this project goes.
Ah, super. Because I think one thing, like if you flip over to the GitHub page and you start looking at the documentation and you look at the work on this, it's all very nicely done. At some point, you run into the fact that Charlie's in high school.
Yeah. Oh, did I not mention that? Yeah.
Maybe like early high school. Like he's 14.
Yeah,
this
14,
is an awesome project. Like this is an absolutely fantastic project for anybody, but for a 14-year-old, it's super awesome. So I'm really, really stoked about that, and equally stoked that he drops by the comments and answers some people's questions. A beautifully done project is by itself inspirational. All right, my first quick hack comes from John Jones. ESP32 powers custom darkroom timer. Darkroom timers used to be, horrible mechanical contraptions or extremely expensive electrical ones. Here he just throws an ESP32 in there, some red, 7-segment LEDs, and, it controls his exposures. He can program in fancy math to do f-stop calculations, the whole damn thing. Really awesome. But what's also really nice about this is that he has a front panel technique where he alternates between a clear filament layer, then a dark filament layer to make the labels here. And it's reminiscent of some of the hacks we saw on the acrylic, and one more coming right up in a second. But before then, Dr. Michael Laufer Little Pharma on the Prairie. This is a DEF CON talk where he is talking about a bunch of easily made 3D printable chem lab synthesis tools. And this is funny because last week we were talking about what's going to be the next big thing. And Christina and I were thinking about bio and maybe some of the open source chemistry stuff, because he's demoing some really neat technology here and tries to make the point that if you make the machines simple and easy to use and accessible, people don't really need to understand the science behind them if they're just able to use them. That's an interesting idea, although when it turns into drugs that you're actually taking, beneficial drugs, I don't even mean recreational drugs, you gotta be a little bit careful. So I'm a little bit two minds here. I think this is really awesome experimentation, but doing science on yourself has always been one of those things. I mean, that's what happened to Dr. Jekyll and Mr. Hyde, right? And the Invisible Man. Don't do science on yourself, kids, unless you really know what you're doing. And last up, Makerverse, custom mini neon signs in 10 minutes. This is a YouTube video about another multicolor 3D printing combined with LEDs hack. Here he does a white layer on the top and then stops the print and then does a black frame around it, fills up the holes with those LED chip-on-bond filament lights that are super cheap and really fun to play with these days. It looks absolutely fantastic, but what I thought was a great contribution to this video was that it also has kind of a basic CAD tutorial in how you turn cursive scripts into something you can print out. So if you're one of those people who has a 3D printer and is like always printing out other people's designs, but don't know how to start making your own, this would be a super general introduction into doing your own CAD design up front. And last but not least, it made me think again of this printing on acrylic thing. What if instead of laying down a layer of white or mostly transparent filament, you just printed the black frame straight onto acrylic, scuffed the acrylic up, you get that nice diffuse acrylic look? That could look really sweet. So see, there, it all hangs together.
Well, for my first quick hack, I've got reviving a 15-year-old Asus EPC with modern MX Linux. For those who might not remember, the Asus line of EPCs, that's 3 E's for anybody counting at home, were the kind of kicked off the netbook surge, or whatever you want to call it, in 2010-ish, where everybody was putting out these like ever smaller and ever cheaper laptops to the point of absurdity with, like 8-inch screens and stuff. Smartphones were in their infancy at the time, which is probably part of one of the reasons where people thought laptops with 8-inch screens were a good idea. This is not, it's a quick hack, right? So there's nothing super hacky here other than dusting off this now, very old netbook and installing a modern Linux on it and kind of just checking it out and seeing what works and what doesn't work. And the answer is it works. So congratulations. Congratulations for keeping hardware out of the landfill. I think it is, an interesting to remember that these even older computers like this, like a 15-year-old computer, it's not any slower than it was the day it was made. Let's put it that way. And as long as you keep your expectations in check and you use the lightest software you can find, they can still definitely be very, very useful pieces of hardware. Next up, I have brass propeller gets impressive hand trimming. And this comes from the Aussie Boat Guy, which this is as far as I can tell, the first project of his that we've covered, which is a little bit surprising, because if you go back on his YouTube channel, he's done some pretty wild stuff that's definitely up our alley. But in this case, he's taking a big old chunky brass propeller that I think he actually said was like a piece of decor on the wall, and cutting it down with an angle grinder to make it a much sleeker race propeller, taking a lot of the weight out of it and making the blades easily half the size. It's a wild piece of work to do with an angle grinder, I gotta say. And when I say angle grinder, it's a bare hands holding the prop and an angle grinder in the other. I mean, I don't even think there's a vice in this whole video. It's all very holding your tongue at the right angle kind of engineering. But it works out, and he tests it in the end, and it's a phenomenally impressive piece of metalworking. I think one of the coolest details here is that, you have to balance the propeller. So to get a quick idea, he chucks the propeller up into a drill and spins it up and just kind of gets a feel for how it's vibrating. Which even in the video, he says you probably shouldn't do this, but I mean, it was a quick way to get an idea how far off he was. And last up, I have the Tiny Tool Kit Manifesto. This is a talk from EMF Camp by Drew Batchelor, and it talks about putting together your must-have tools. This isn't the big box of every kind of plier and screwdriver that you keep at home. This is the stuff maybe your daily carry, if you want to call it that. This is a little thing you can keep on you, and to keep it small and efficient, you got to figure out what you really need. And the presentation kind of goes into the idea of recording, every time you use a tool, and kind of building up a little spreadsheet for yourself and saying, okay, well, I use this 3 times in the last month, and I use this once, and eventually you get to the point where you can figure out, like, what do you really need and what do you not need, and are there things that you could use for multiple purposes instead of a single purpose thing. And it's just an interesting look at how to kind of maximize the efficiency of what you're carrying with you. And it's a technique I think that could work beyond just like the small toolkit. I mean, I think we could all probably use to have a little bit more efficiency on our workbenches and that sort of thing. So just an interesting talk and an interesting way of looking at what tools you're actually using versus hanging up as decoration.
All right, that brings us to our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. And this week I wanted to cover, well, it's a SuperCon presentation written up by Lou and Day, given by Sonya Vasquez. So it's like, is Hackaday all the way down? This is Sonya's presentation from SuperCon 2023, The Road to Writing Great Step-by-Step Instructions. And for those of you who don't know, Sonya runs the tremendous open source 3D printer with a tool changer project called Jubilee. This talk is kind of focused on how she's grown in terms of her documentation and build tools for the people who want to build this open source project. And I think that's really neat because a lot of the time when I do hacks, I'm just doing something. And if I write it up, it's always kind of after the fact. But some of these really bigger projects, she's already thinking, hey, I really want to share this with a bunch of other people. And if you want to share it with a bunch of other people, what are you going to do? Well, you're just going to give them the design files and be like, good luck, kids. Go nuts. No. And the answer is, if you want other people to do it, you got to make it easy for them to do it. And the way to make it easy for them to do it is great build instructions. Sonya's done so many workshops and open source projects that other people have built and actually listened to and acted on the feedback she's gotten back from them, that this talk is just full of fantastic tidbits. And you should absolutely watch it if you want to make a project that people actually build. Because, and I can't stress this enough, this is where the rubber meets the road. This is between the person who wants to build your project and actually building your project. This is the thing that's in between, and making that as frictionless as possible is a total winner. She draws a lot of inspiration from Lego and IKEA. They have really great kind of sequential step-by-step graphical instruction diagrams. And she takes some hints from them, including things like, lots of little steps, and from Lego, lots of little sub-assemblies that then go together in bigger assemblies. But then there's a bunch of other interesting kind of insight here that I didn't have, like if you're doing this assembly on a table, make sure everything is oriented like it would be with gravity, because it takes that step out of your users that they have to turn it over in their head, right? How many times do you see these exploded diagrams where the thing is just, exploding sideways out into space, and you're like, which piece goes first? What is this? Where is that? And I'm sitting here looking at one of these things on the table, and now I see this exploding thing that's rotated 90 degrees, and my head hurts. Her point is, don't make people's head hurt like that. The other thing that she insists on that I think is really nice is to put a table of the pieces that you need on every step. So, you can tell if you've got the right pieces to make sure that you're going to put the right widgets in the right holes. Because, all screws look alike when they're printed out in an instruction manual. And so you have to help people out and say, this one's this one. And those life size, printed to real scale guides so you can line the screws up against them are great. But even just a list where it's like, you need this one, this one, this one, this one for this step saves people from, making horrible mistakes. Oh yeah, and another is that Sonya's doing a lot of stuff with 3D printed parts, and of course it's a community project, so people are improving the 3D printed parts. And the question is, which version of the 3D part do I have in my hand? And I know she's written this up before too, but she has a system where she labels the parts both with the name of the part and the revision number. In fact, often a GitHub branch number in the part itself. So it's 3D printed, you just emboss that in, right? And that is super useful if you then have a diagram that says you need this part serial number A17, and you can actually just look on the part and the part says A17 on it. Then you've got the part's orientation right, you're absolutely sure you have the right part in your hand. It just makes it super, super simple for the people who are actually trying to do the work and put it together. She ends on wiring diagrams. Her wiring diagrams are absolutely beautiful. She says make lots of use of color because it helps people tell things apart. I love her conclusion to this whole thing is that instructions can be very beautiful. She says, I want you to have the diagrams be like, I'd get that on a t-shirt. Like that's a good sign that you've done your plug this into that diagram right. And I kind of like that idea.
That's a good metric. We got to use that for a contest or something.
I'd get that on a t-shirt.
One of the honorable mentions, like, yeah, I'd get that for a t-shirt. I feel like we've said this a lot of times, but documentation is so key in having a successful. I guess you'd have to say community, right? Because
absolutely.
you could do a project and do no documentation other than whatever's in your head. And you're free to do that, and I probably would hazard that that's what a majority of people do. But you're never going to really build anything around that. If you want to have other people recreate this, and you want them to contribute, and you want to make some kind of a flourishing thing around a piece of hardware, you got to have not just good documentation. You got to have great documentation because that's going to be so key to getting people involved in the first place, but then also to contribute it, right? And it's hard. It's not fun necessarily. I think a lot of us enjoy the making of things way more than we do the taking pictures and the writing up of how you did stuff and remembering to, did I mention this pitfall or that pitfall? So it's a challenge, and I have a lot of respect for the people who rise to that challenge and are willing to do it. And talks and presentations like this, are they as sexy as some of the other stuff? Maybe not, but they're very critical, and I think there's a lot to learn from it. And you do well to watch it and kind of reflect on it and try to implement some of those things in your own workflow.
You said something that resonated with me, the kind of, did I take enough pictures of it sort of thing. She's doing documentation as its own project itself, I think, here. And it's really, how can I make a documentation system that's so good? And I think that's actually an interesting challenge. And I think it's a totally different mindset. Like when I do a project, and from what you just said, sounds like we share this, I'm interested in doing the project. And like, I see things like, am I taking enough pictures? As takes me out of the flow, distracts me sort of thing. Yeah. But this is something entirely else. This is, can I later, after I've done it all, describe what I did so well that someone else can do it? And what are all these tricks that I can do to it? And I think it's, it's a whole nother level, but it's also a really interesting challenge. And that's what actually comes out of this talk for me, is that Sonya's really seeing this as a fun thing to do. It's not, I'm making documentation and this is, I'm just taking pictures and writing what I did, because that's kind of crappy documentation. And maybe that's why it's so dispiriting to do it, to go through these steps. And here instead, she's really like, it's like she's playing golf with the documentation. It's just like, can she do better? Can you do better here? Can you improve this bit? Can you improve that bit? And I think that's actually incredibly motivating, especially if the end game is to get a bunch of people to rebuild your project. Then it's also motivating on that side. Yeah, I think maybe have I put a camera above my desk and am I clicking the button often enough is like a killer in terms of motivation for doing the documentation, even if it's better not taking the pictures, right? But it's not doing the documentation, it's shortcutting the documentation. I think that the kind of joy of like really hardcore doing the documentation is, doing the instructions right is what comes out of this talk.
Well, my can't miss this week is from Arya. This is Switching Regulators, Mistake Fixing for Dummies. And I really like this one for two reasons. This is, maybe it's three reasons? Maybe three reasons I like this one. I really like this one. On one hand, this is another entry kind of sort of into Arya's ongoing project to revive a Sony Vaio handheld with a custom motherboard that's going to hold a Raspberry Pi and integrate with all the original hardware, which is a really, really cool project on its own, and very cutting edge, like reminder of like what the modern hardware hacker it can do with all the tools at our disposal. So that's really cool, and I like to hear more about that. It's also kind of an entry in her series of deep dives into different electronic fundamentals, in this case, a voltage regulator. And that's cool. And the third one, I knew there was a third reason, is that she messes up and she kind of owns up to it and says, did a couple things wrong with this design, but rather than tossing it, she creates this like little parasitic PCB that can stick on top of the existing boards and fix them without having to toss them, which is, that alone is like a hack that could have probably been spun off into its own thing, which is really cool. So you should read this one. But so that's the high level, right? This but like to break it down, starts with a relatively simple list of requirements, which I think are common enough in our field. You want 5 volts, you want a decent amount of current behind it, and you want to be able to run that from a LiPo that's going to be 3 something-ish volts to 4-ish, right? You want that kind of range. But then you also want, if there's 5 volts available, like if you're plugged into the wall, then you just want it to run off that and bypass the regulator entirely, so you're not eating up any energy unnecessarily. And I think that's kind of that's the sort of thing that we all probably have looked for at one time or another. Like I got batteries, but I need 5 volts, and I want to be able to charge them, and I want to be able to do it efficiently, right? So this seems like it should be an off the shelf kind of thing, but she goes through, and it turns out had to go through a bit of working to find one that hit all those checkpoints, and ends up with the MIC 2876 chip, which she had not previously worked with, but said, okay, well, I'll follow the data sheet, and I'll look at the example usage and how hard could it be, right? It's a regulator; they're not super complicated. And then, gets the boards back and starts testing it and starts having some problems. And one of the main ones, it's extremely noisy. As soon as she puts power to it, it's making this noise. And they're like, well, that's not good. And, not to get too deep into it, because it's not really the most important part of it, but like the regulator works at 2 megahertz switching speed, which is pretty high. And, 2 megahertz is fairly high for one of these regulators, and there's a little bit of like territory unexplored there for her. So she wasn't 100% sure what to expect. And, long story short is that while she had kind of all the parts that were necessary as explained from the data sheet, the layout itself wasn't really ideal. She talks about like the feedback divider is supposed to be after the capacitors and not in between the inductor and the capacitors. And then when she gets even deeper into it, like her grounding routing was not ideal as explained in the documentation. From that point, it picks up with, okay, well, I had these boards done. There's a considerable investment here. All the parts are here. They're just not necessarily connected in the right way. And what can I do about that? And then she goes into a whole other hack where like she shows how you can take an existing PCB in KiCad and basically like use the placements and do an edge cut around it, so you can have this little board with like castellated edges that can solder between the components. It's really a wild thing, and man, I probably would have thrown the boards away and started over. Like, but this is definitely the better way to do it. You know, it's the kind of thing where you might never need to do this, but it's cool to know it can be done and to see how it can be done. And she breaks it down, and it's not, this is not like there's not a button in KiCad for this. Like talks about literally having to like open the text files for the project and copying stuff out of it to get the things right. Like, this is definitely, this is a proper hack. But the end result is a really cool, like, conformal board that, would be very difficult to have figured out how to do freehand, if you didn't have this guide. So a lot of cool information in this, a lot of lessons learned. And she said in the end that she would mention it in the comments, because I think she was still waiting on when the boards came in. So I don't know if we did get a final result on how they worked. But honestly, even if it didn't work out, it was fun to be along for the ride and see all the work that she put into it.
Yeah, I love the solution. It's absolutely insane to kind of make I don't know what it is. It's like a patch that goes over the top of the other PCB. Like, it's a literal patch that connects up to some otherwise through holes on the thing and fixes it. And I think that's just, I mean, A, it's bonkers, but B, if that's the solution, that's pretty cool. And it made me think that you could, if you're doing a PCB design that has kind of parts that you haven't tested out yet in it, I wonder if you could design kind of like this on purpose, like make little modular spots on your PCB where you're like, this is where the power regulation circuitry is going to go later.
I just don't know what it looks like yet. Yeah.
But it's going to be 4 centimeters by 4 centimeters, and it's going to have the power pins here. And you just put those through holes on there and like plan at a later date to, make 2 or 3 different daughter boards that would go into that spot and test it out. I think it actually sounds like a kind of cool intentional prototyping system.
I was going to say we could, put that in the show notes, but I mean, she wrote an article that was not unlike that, I think, where she said, embrace the modules that are on the market. And if there's, like the common lipo charging module that you can get for 50 cents, like, why re-implement all that on your board when you can just put a footprint where, you could just solder that module right down. Right. So, yeah, I guess you can, really, instead of committing to everything right up front, just be like, okay, if you have the space for it, like in this case, it's pretty tight because it's going to go into like a little palm top. But yeah, absolutely. Like, just here be power regulator. Just leave a square and we'll figure it out later.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you'd like to follow along with the links, they're over at hackaday.com/podcast. And if you want to send us any tips, email tips@hackaday.com. And until next week,
keep on hacking. It's crazy how time flies.
Wait, why is 25 minus 4 21?
What? What did we say?
What year is this?
2024.
Oh, no, this is 24.
There's some internal disagreement about the current date at Hackaday. Talking about, like, scientists that experimented on themselves. I was wondering what example you're going to go with, and I didn't anticipate the Invisible Man.
Didn't he do that? Wasn't it?
I know he did. He did, but I thought maybe it'd be somebody, who existed. I wasn't sure.
But you're right. Neither Dr. Jekyll nor the Invisible Man are actual people. Bruce Banner.
There you go. That's a real scientist.
Thank you.